Hello everyone, how are you? What we're going to do today is I'm just going to give you a quick little tutorial on what we call the coefficient of variation. It's the last part of the measures of variation section of 2.4. What this is, it's a numerical value that allows you to compare two separate sets of data. So for instance, if I'm looking at the height and weight of a certain sample or a certain population, I can figure out which varies more between the height and the weight. The reason that's difficult before coefficient of variation, the reason that would be difficult is because, the weight is in pounds and the height would be in inches. So they have different units, okay? But if we compare them, if we look at something called the coefficient of variation, you can tell which has a higher percentage of variability, okay? The way to find that, you simply just take you take the standard deviation, you divide it by the mean, and then you times it by 100, and it'll give you a percentage to consider. Okay? So the example that we're going to do right now is an example from the textbook. And what this does is this is comparing two data sets, and it's all the pitchers from the 2013 St. Louis Cardinals, the baseball team. Okay? And in this, what we have is we actually have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 pitchers, and it's all the pitchers from this 2013 team. So we're talking about the population, okay, a population. So when we look here, you can see all the ages, you can see all the heights. Well, in order to find the coefficient of variation, what you need to do is you need to find the standard deviation. You divide that data's standard deviation by the mean. And that proportion, you're going to times it by 100. Okay, so let me explain. First thing I'm going to do is I'm going to go put all my ages into L1. Okay, so if I go over to stat, I bring this over. Okay, and I put all the ages inside of L1, and then I put all the heights inside of L2. And for both of those, I ran a one variable stat analysis. Okay. And when I ran the one variable stat, this one is for ages, okay? When you put it in, you find a mean of 27.16 repeating, and you'll find a population standard deviation of 4.297, okay? So I have those two values. You simply just take that 4.29, you divide it by 27.16, and then times it by 100, and it'll give you a percentage, okay? So let's go bring up our calculator, okay? And inside the calculator, I'm going to go out to the main screen so I can just calculate this. So I'm going to do 4.297, okay? And then I'm going to divide that by the mean. So it's standard deviation over the mean. When I press enter, and then I times that by 100, you'll see that the coefficient of variation is in fact 15.8%. Okay, so the coefficient of variation is 15.8%. Okay, so now that was for the ages. Okay, that's how it varied. Okay, so now I'm going to go over and now I'm going to look at the other set of data, which is the heights. Okay, of the players. So I already ran a one variable stat on that, so I'm going to do 2.0138. Okay, I arbitrarily just choose 2 or 3 decimal places. And then I'm going to divide that by 74.6 repeating. And now once I have that, and I times it by 100, okay, you'll see that the percent here is 2.7%. So which varies more? Which has a higher variability rate? Well, it would be the ages, 15% or almost 16% compared to the 2.7% for the height. Okay, so that's all you do. You just want to figure out using the coefficient of variation, which set of data varies more. Okay, and that's all there is.